Welcome to the Private Wireless podcast series from Nokia, bringing you the insights that really matter around enterprise digital transformation and wireless solutions. The series covers technology comparisons, deployment best practices, total cost of ownership assessments, analyst reviews and reports to help you make the decisions you need for your business. So keep listening. We're joined again by James Blackman of Enterprise IoT Insights as he chats to Stefan Doble, Head of Marketing at Nokia Enterprise Solutions. Today's episode compares the total cost of various wireless network technologies, including private wireless, which, if not always the deal breaker, is a question that invariably comes up and one that needs looking into.
To start with, Stefan, perhaps you can give us an idea about what enterprises, and particularly industrial enterprises, need today in terms of connectivity. There's a lot going on in there, right? Especially in these kind of heavy industrial sites with business connectivity and machine connectivity and everything else. Just if you can, set the scene for us.
In most industrial sites, you've got a combination of different application domain in the same place. So, if you take a look at it, for example, even if it's an industrial plant, you may have, administrative office there as well, where, you'll want, your employees or even your sales team to be able to receive phone calls on their mobile phone, for example. So one of the area of connectivity in an industrial site is just the mobile operator expanding and extending its coverage indoor so that the traditional CSP service continue to function. Then you will have also the IT team that's responsible for the LAN, effectively the LAN connectivity and the Wi-Fi connectivity for the traditional business type application, typically on best effort. And then on the same plant, then you will have also what we call critical applications. Typically, these are driven more from the OT side of those enterprise, and they have their own set of requirements when it comes to reliability, security, etc., and tend to use different type of technology. So it's important that we understand when we talk about private wireless that the technology we're talking about is focusing on what we call the OT side of communication and the OT side of the application domain versus the IT side that's typically more handled by technology that we all heard about, Ethernet or Wi-Fi, etc.
Right. So let's talk about that OT piece then versus the more familiar IT stuff, if you like. Why is private wireless so important in that domain of critical industrial connectivity?
While it's often a joint project between the IT team and the OT teams tend to be the one that derive the requirements for their kind of connectivity. And typically it's been mostly handled with wired connectivity, and more, and with Industry 4.0 transformation, there is a need to connect more and more assets. And, the OT team are expecting to get the same kind of performance and reliability and security they used to with wired connectivity now going wireless. So when we take a look at these specific OT needs, there is some key requirements, for example, around coverage and penetration, which is important. And when you take a look at technologies such as Wi-Fi, and while Wi-Fi has improved significantly with the with the new coming of the Wi-Fi 6 standard, that mostly focus on increased capacity, increased user performance, and a bit better latency, there's still some significant challenge when it comes to meet the OT requirements. In terms of reliable performance is another aspect where private wireless networks really makes a difference. Not all applications need extremely low latency, but you need a very stable latency. And the same thing with data rate. Like when you plug a LAN cable into a machine or laptop, you're almost guaranteed you're going to get 100 meg or 1 gig performance. What is the same thing that OT guys expect from a wireless technology. The other aspect of it that's important to consider is security. As soon as you bring a wireless technology, there's increased security risk around the use of this network. And in that sense, private wireless also brings significant value. The 3GPP technology that LTE 4G comes from, or 5G, I've inherently built the security standard end to end. And with the use of SIM cards as well as end-to-end encryption on the network, makes for extremely strong and sturdy security system. And that's, those technology, there's some of the reason why those technology are used even now for defense or even public safety. The other aspect that's important as well for OT is the ability to have a single wireless network for all their applications. And that's something that we've seen in many of the industrial we work with, where they often have very different and many multiple networks for different applications, sometimes even one wireless network for one application. And with private wireless network, they also get access to what we call LTM or narrowband IoT, which enables to a very long battery life sensor, and effectively that enables you, for example, to digitalize old machine. And again, that's come standard as part of LTE 4.9G, where you can have a sensor that can have a 4-year battery life that enables you to digitalize the machine. And again, that comes standard on private wireless. And finally, the last point, but it's an important one, is the aspect of mobility. Whether you're talking about a port or mine or even a factory, there are a lot of things that move, and the mobile credential of 4.9G LTE networks are very important when, again, it comes to keeping reliable, low latency and high data rate, even during handover. So this is another aspect that also very different for and required for the OT applications.
So, Stefan, it seems, and this is perhaps a simplistic way of looking at things, but it seems very much that all of these connectivity technologies have different purposes and serve different functions. That essentially Wi-Fi is well suited to IT and kind of office communications. Private wireless is geared for the critical OT piece, and then you have public cellular in the background for general connectivity and even some kind of light touch IoT sensing. So if that's the case, how come in this conversation around OT and the OT space, how come Wi-Fi keeps coming up, as a contender even on the factory floor and in this industrial market?
Yeah, I mean, you are correct. And while we are clearly seeing from a number of surveys or some data from analysts that private wireless using 4.9G LTE and in the future 5G is becoming, the default choice when it comes to OT connectivity, Wi-Fi is still very much prevalent. And there's a couple of reasons for that. And the first one is, those projects for OT connectivity often involves the IT team as well. You have to work together to have a single network, the same range of IP addresses, etc., for example. And so often the IT team are involved in those discussions, and by default, IT bring their own technology to the table, and that's one of the reasons why we see Wi-Fi still being a technology that's kind of prevalent in those discussions. That's probably the first point. And I think the other point as well is the vendor of Wi-Fi technology do not necessarily understand, they're not necessarily radio expert and do not necessarily understand the free GPP type of technology and the difference between them. So they just assume it is fine. When in reality, as we talked about before, there's a couple of key areas where really private wireless makes a big difference. And then, finally, just Wi-Fi is so prevalent, in almost everything we touch. There is a perception, of Wi-Fi also being low cost. And while, the aspect of TCO is indeed something that not the top of the pile, is still an important topic. And indeed, people believe that Wi-Fi at least it has a perception of being a low cost solution.
So, Stefan, maybe you can bring that home for us a little bit. In terms of this cost calculator tool for private wireless you've developed, is there a tipping point at which private wireless starts to make sense? Is there a rule of thumb for that? Or is it really the case that everything has to be taken in the round and performance is everything and pays for itself in the end? Just talk around that if you can and run through an example of how the maths works.
As I said, it is quite a complex view, but from that we were able to derive a few key rules of thumbs. And typically when you look at a private wireless networks, the increased cost aspect that we talked about regarding the spectrum, the cells, and the core network, they are typically compensated for in terms of cost when you have an industrial site that is above about 25 to 50,000 square meter in terms of indoor space. So, beyond that size, the coverage and capacity benefit of private wireless does make up for this increase in cost. But then, the tool, also made it pretty clear to us that any industrial site that have challenging radio environment, and I'll come back on that in a second in the example, clearly private wireless networks makes more sense. And then the final key learning was also around, the the outdoor side. And most of the industrial side that we talk about have the need to also cover the outdoor space. Or in other instances, like a mine or a port, or almost the whole use case is actually outdoor. So when you take about large coverage, this is another area where private wireless almost ever win on the total cost of ownership. So that was, the generic trends here. But, from a very concrete point, let me give you an example that actually was probably the thing that kickstarted this whole project, this whole idea here. We've got sometimes the occasion and the chance to get a direct comparison to the competing offer. And that was the case here with a deployment in North America on a very large process manufacturing type plant with extremely high ceiling, very large, and very long, machines, obviously made of metal. And we came to get to the information on the competing Wi-Fi offer and realized quite a few things, and probably the most anecdotal, information we got was the planning and network design aspect of Wi-Fi was actually, more expensive than the complete offer for a private wireless network. And let me explain why. So, when you take a look at, Wi-Fi, one of the issue is around the coverage aspect. Because it uses unlicensed spectrum, it's limited in terms of output power. So you end up with a very small coverage. But when you have no choice but to put those Wi-Fi access points very high on the ceiling, which is often the case in those large industrial plants, the coverage on the floor is extremely tiny. So in that case, they effectively had to, plan and use what is called directional antennas to even be able to create a big enough coverage on the floor for the whole network to make sense. But that, involves quite a bit of work in terms of planning and, and survey time. So effectively, while, we were able with private wireless to do the whole, radio survey, planning and design in a matter of a couple of days, for Wi-Fi, they almost need a month, if I'm not mistaken. So that meant they had to spend a lot of time surveying the site, understanding where to best place the access point, what type of antenna to use, what direction to antenna. And then once they've done all of that, the challenge they had is because of the the environment you're operating in, because it's a fast-moving environment. You may have, a forklift truck that will pass by. You may have a new machine that's implemented the next day. That also creates some challenge with Wi-Fi because the coverage is so limited. It can create shadow, but also a lot of interference. As you can imagine, there's a lot of metal in those places, a lot of reflection, refraction, which, Wi-Fi doesn't like. Wi-Fi works by effectively avoiding interference. Private wireless works with interference. And that's a big difference. And as I talked about earlier, the coverage aspect, the much bigger coverage you have, with private wireless makes it a lot easier and cheaper. So bottom line, this example was one of these occasions where we felt we needed to understand this topic a lot better, because there's clearly a lot of factors in play, not just the cost of the hardware, but also, the installation, the planning, the design, etc., were also a very important aspect to consider.
So, Stefan, just to sum up then, it seems there are some misperceptions still around private wireless in the market, and specifically around cost. And as a rule, if you're looking to cover an industrial site of over 25,000 odd square meters, then that cost differential really disappears. And it's a no-brainer almost to go with private LTE and 5G. And if you are less than 25,000, then perhaps Wi-Fi might make sense from a cost point of view. But at the same time, private wireless introduces all kinds of critical grade functionality and performance on top. And actually the perception alongside that Wi-Fi is, a plug and play and simple to understand technology is not always the case, especially in these complex industrial environments. And, cellular might take some learning, it seems, but it is inherently more capable and suitable in this OT market. Is that the case? And tell me, what else should we be thinking about here? Because there is a lot going on.
That's about right. So we, just give another example here. The open pit mining space is another one where, as soon as you got a wide area, a complex radio environment, which is often the case in the industrial side, then clearly private wireless makes a lot of sense from a TCO point of view. But it's almost a no-brainer, because if it's lower cost and also better as a technology for OT, then it's an easy choice. But there are a few other things that we discovered and learned a bit more as we kind of deployed private wireless networks and work with some of our partners that have been in that space for a long time as well. and partly talking to some of our partners that also deploy and manage Wi-Fi network. While there is clearly, a slightly steeper learning curve on private wireless, although, the industry and Nokia has worked really hard on making those solutions simpler and more enterprise friendly, because it's a different kind of technology for the IT team. There's a little bit of a steeper learning curve. But one of the things we found out that was interesting is the Wi-Fi, there is a perception of a certain simplicity, and it is correct. We all using it in our house, but in a difficult environment and a fast-moving environment like we are talking about, with machines, with metals, with partition that comes up and down, with a mine that expand and shrink depending on the amount of explosion and the drilling and digging they do. The reality of it is a private wireless network is a deploy and forget, whereas a Wi-Fi needs constant management and reoptimization of the network to ensure that the performance is guaranteed. And we had a few cases, for example, in the mining space where effectively the Wi-Fi radio folks were almost coming back every week to readjust the network in line with the new topology of the mine. So that's one aspect as well. And then probably the other thing that we have not considered, but it is something that's also important, is the ability of a private wireless network to be the single wireless networks for all the application. That is something that's very important. I talked about this earlier. The support for LTE-M and narrowband IoT makes it also a very good network for sensors, low power sensors that are used so often in those environments, and that where we need more and more to digitalize machine or connect assets and trucks, etc. But also the aspect that very often when we walk to those sites, there is typically an older legacy critical voice system, either P25 or Tetra, etc., what we typically call push to talk. And very often the enterprise we talk to are also looking to upgrade that solution and make this critical voice run on the private wireless networks. And again, as you know, voice is something that we've had since the GSM days. So private wireless is really a solution that's very suitable for that. So effectively with private wireless, you save on cost as well, because you can have a single network to handle both your critical data, to handle your, let's say, your sensor network as well, and also your critical voice.
Our thanks to James Blackman of Enterprise IoT Insights and Stefan Doble, Head of Marketing at Nokia Enterprise Solutions, for joining us today. It's really interesting to hear them discuss the common misconceptions of Wi-Fi versus private LTE. It seems private wireless solutions are the way forward, particularly for large industrial campuses. Thanks for listening to the Private Wireless podcast series from Nokia. Don't forget to subscribe and be the first to hear new episodes. If you're looking for more insights around all things private 4.9G LTE and 5G, contact the Private Wireless team at Nokia. To find us online, just search for Nokia Private Wireless and click Talk to an Expert to get in touch.